What's up, all you cool kids out there? Hey, it's STEM with Mr. C. And yes, your eyes are not deceiving you. I do have a bunch of diapers here because we're going to be doing something called Diaper Science or Diaper Engineering if you want to be really technical, because there's a lot of engineering that goes into making diapers. And so we're just going to jump right into your materials. You are going to need, obviously, a diaper. Does not matter what kind, but at the end of this, we can talk about kind of some experiments to basically take this to the next level, right? Because I'm going to show you how we can measure this, and then we're going to just take it up to 11, turn it up to 11. Okay, so diapers. I'm actually, I've got some men's, you can see these are huge diapers. This is like a big baby. No, these are actually these men's, you know, like Depends. And I was at Big Lots, not bragging, and I was getting other things. And I'm like, oh, I'm gonna get some diapers here. They'll probably be pretty cheap. And they don't sell babies diapers at Big Lots, but they do have a whole section for men and women diapers, which I found interesting. So I just went with this, and there's also going to be a lot of what we're looking for in here. Okay, which I'm going to tell you what that is in a minute. So anyway, diaper, check. Scissors or some sort of knife, because we're gonna do some surgery on our diaper. We're gonna cut it open. Check. I do recommend a Ziploc bag or some sort of sealable bag. You don't need to do it if you don't have one. You can easily do it on a table, but I also recommend having some black construction paper or dark construction paper just so it doesn't get all over the table. This just helps because we're able to basically get everything that we need out of there without it going up in the air and getting it and breathing it in. I have a scale. You don't need it, but I'm going to show you kind of how cool the substance in here, which I'm going to talk about what it is, how cool it is, and how much water it can actually hold. Speaking of water, you are going to need some water. I don't need this much, but start off with about 2 cups and then we'll go from there. Food coloring is always fun. We'll do a little experiment at the end, but I'm going to show you, and they also use it in all the diaper commercials because apparently everybody, when they pee in diapers, pees out blue liquid. Who knew, right? And then some sort of container to put our stuff in. So I have everything from a mason jar. I also have a graduated cylinder. I don't expect you guys to have these, but I'm gonna do it in here because it looks fun. Plus, these are really smart, because they graduated. Anyway, enough of my horrible jokes. Let's talk about why we're doing diaper science. So if you've ever seen a diaper, if you've ever seen a baby in a diaper, obviously it keeps their poop and pee inside the diaper, right? And you've noticed like a regular diaper doesn't weigh a whole lot, but then obviously when a baby poops and pees in it, or let's just stick with pee, right? Let's not talk about poop. Pees in it, that diaper gets really heavy. And you probably, well, yeah, obviously the material, the cotton and everything absorbs the water. Of course it does, Mr. C. But there's actually a special chemical in here called sodium polyacrylate. Let's say it again, sodium polyacrylate. We know our old friend sodium, right? It's in salt and everything. And it also explodes when you throw it in water. We've probably never heard of polyacrylate, but you probably know what a polymer is. And if you don't know what a polymer is, you want to go all the way back to one of our first videos up here, where we jammed pencils into a Ziploc bag, and surprise, surprise, they didn't leak thanks to the power of polymers. So there is a polymer in diapers. And we are going to do some surgery, get it out, and we're going to see how strong this polymer is. All right, so obviously that's already a vocabulary word, polymer. Let me tell you 2 other vocabulary words. One we're gonna use and the other one is just the opposite of it. First, the material, the polymer in here is something called hydrophilic. Ooh, good word, hydrophilic. So if you break that word apart, hydro meaning water, and then philic meaning likes or drawn to or attracted to. So something's hydrophilic, it's drawn or attracted to water. Pretty cool, right? Look at that, language arts and STEM. I know, you guys are getting a deal here. And the opposite of that, you guys have probably seen when you see water bead up on leaves or bead up on your jacket and you don't get soaking wet. That's called hydrophobic, right? Same thing. Hydro, meaning water, and phobic, meaning afraid. So if something is hydrophobic, we call it afraid of water. Not really afraid of water because your jacket doesn't have feelings, but it's just, that's what we call it because it repels water. So we are gonna take apart our diaper and we're gonna find sodium polyacrylate, our polymer, our hydrophilic polymer, and we're gonna see how strong this stuff is. All right, once you gather all your materials, we're just gonna go ahead and start cutting up our diaper. Here we go. Okay, so here is my very large diaper, and we're only really concerned, and I'm gonna rip this open here. All right, we're only really concerned, obviously with all this stuff right here, this nice padded material. So everything else you can just kind of cut away. It'll make it a lot easier. So I'm gonna do that now. Okay, so this is all the stuff we're looking for, okay? And to get to this, we're gonna cut, there's a little layer of cloth right there. We're just gonna trim it away. And however you want to do that, I like to just make a little incision there, right? And then you just take your scissors under, and then you just cut away. Don't worry about ripping anything in here because we're gonna figure out a way to get it into our bag. So just make a nice little incision and then from here you can rip. There we go. Look at that. Now, look at that. Doing a little surgery on our diaper. Now here, look at it, look at all this stuff. Really, really cool, right? Now you can probably see, if you're looking at it, and you move your head around, you get a bright light shining, you can kind of see it glittering, right? It almost looks like there's glitter in there. And I don't know if I can get you guys to see it there. Probably not, move it up and down. You might be able to see some glitters. But that's the sodium polyacrylate in there, right? That's what we need to get out and put in here in our Ziploc bag. Again, if you don't have a Ziploc bag, you can always just dump it over onto your cardboard or your construction paper or whatever, and then when it looks like little bits of grains of white sand, you know you're gonna be good, okay? So all I'm gonna do, and don't worry, this is non-toxic, okay? So you can touch it all you want, not gonna hurt you. Don't eat it, don't drink it, don't put it in your eyes, don't put it in your ears, don't put it anywhere. Just, it's okay to touch it, but really that's the extent of what I want you to do. Okay, so I'm gonna take my Ziploc bag here, and all I'm gonna do is just very carefully, I'm going to take chunks of this cotton, and I'm just gonna put it in my Ziploc bag as carefully as I can, right? Because there's the sodium polyacrylate in there, and I don't wanna get it everywhere, because I wanna have as much of the stuff as I possibly can, okay? The Ziploc bag just makes it really, really easy to keep it all in one spot. You don't have to use it. It just makes it a lot easier, right? And there's even some all right here that I'm gonna use, okay? So then what I'm gonna do, I'm just gonna dump it over and I'll show you. Mr. C, why are you doing that? Well, I wanna show you, right? Because there's a lot of stuff there and now it looks like sand, right? Look at that. Well, that's your stuff. That's what we want because there's a lot of it here. And then you can just gently, just like it's snowing, right? And that is all your sodium polyacrylate right there. So you see I'm just stripping away the cotton. We don't need the cotton. Cotton's not gonna help us. We don't really want that. I mean, it helps the baby. Because imagine if you didn't have the cotton, you'd basically just be sitting in a big pile of gel, and that's no fun. Nobody wants that, okay? So you can see that is quite a lot, right? Because I got a very large diaper. And so all I'm gonna do is I'm just gonna gather up all of my cotton, pick out your cotton right here, right? Because that's not, we don't want that. So you just pick it out as best you can. If there's little bits, you'll be fine. Just pick it out. And there we go, that's pretty good. And then all you have to do is Look at that. See, I spilled a little bit there, but that, hey, I have it on my cardboard here, so I'm actually pretty good. Now, I'm gonna put this to the side because I am gonna use that. But here, we still have a lot more. And so I'm just gonna seal this up and really I'm just really going to mash it up, right? Shake it up, right? And you're gonna see, I get a little bit more. Look at that, I get a lot more there, right? You see that? That's all the sodium polyacrylate there. So just mix it up, right? Strip it out as much as you can. All right, so look at that, and that's just out of the cotton. Look how much that is. That is a good amount right there. Plus we have all that stuff, and then I have a little bit I spilled here. So I'm pretty pleased with that. And I'm gonna do one more. I'm just gonna take my cotton balls here. I'm just gonna gently shake them out. There we go. Put them there. Take the rest of the diaper cotton. And the diaper cotton does absorb water, so it is very helpful to the diaper. There we go. Beautiful. Oh, dropped a little bit there. All right, so then I have this. I mean, look at that. That's quite a bit, and I still have this all the way over here. So what I'm gonna do is I am going to find a good way to just put this so I can pour it. And I wanna be able to measure this. I'm gonna measure how much this weighs. So let's go ahead and just pour it in there. Now, as you do this, you see everything's kind of flying around. That's just usually gonna be the cotton fibers. There we go. All right, so now you've probably noticed, oh, I've got some little fluff balls in there, and that's okay, you can just take those out. It's gonna happen. All right, take those fluff balls out. Not the end of the world if you don't get them all, but do your best. There we go, and there we go. I'm fairly satisfied with that, okay? And I'm gonna take the rest of it, and I'm gonna pour it in here. There we go, and there we go, beautiful. That is a lot. I mean, it almost looks like snow, which you can make actually snow with this. But look at that, that is quite a bit. And let's get that little bit right here. I've got more. There we go, get as much as I can. And then obviously the rest of it, you just vacuum up. Again, it is non-toxic, but yeah, don't eat it, drink it, make a smoothie with it. You don't wanna do that. There we go. Okay, so now we're gonna weigh this. Because it's kind of, you don't have to weigh it, right? You can just, if you don't want to weigh it, just go ahead and skip ahead. But it's an important part of our science, right? Is we can just do the experiment, but you also want to measure, like, okay, how effective is this diaper? How much of this is in here? How much water are we adding? All of these questions, right? So there's my scale, and we're gonna go ahead and turn it on. Okay, so now I'm not gonna use this because obviously if I just weigh it like this, it's gonna say, oh my goodness, 378 grams. Clearly I don't have 378 grams because I haven't measured this yet, right? So what we'll do is I'm going to use my graduated cylinder. Okay, so you see my graduated cylinder weighs 24 grams. Okay, so then you see this button called tare. Just gonna click that. No, really, click it. There we go. Third time's a charm. And that just zeroes it out. So basically I'm telling the scale, ignore my graduated cylinder. I want you to ignore the weight. I don't care about it. All I care about is all of this goodness in here. So then we're gonna go ahead and, beautiful. All right, get as much of it as I can. And I'll bet you there's not even gonna be that much, probably barely a gram. Barely. I don't even think there's a gram in here. We can actually see how much there is. So it doesn't even weigh a gram. Let's see if it has anything else. Doesn't even show it. So not even a gram, okay? And I don't have a small enough scale to go below that, right? So I don't know what fraction of a gram it is. I have no idea. But this is kind of important, right? Because we're gonna show how much water this holds. So basically almost a gram of sodium polyacrylate. So our next step, and if you wanna do this, you can. I'm gonna take this, I'm gonna leave it on the scale, and just for visual representation, we're going to dye my water blue. Right here, you can see me dye my water blue. Okay, stir it around a little bit. There we go, beautiful. All right, and then now, I'm just gonna add it slowly, right? So right now I have 2 cups of water. I'm probably not gonna add that much. This is just to show you. So let's go ahead, pour this off. So I wanna have, I'm not even gonna use cups, I'm gonna use milliliters because we're gonna be all scientific, all right? And this only holds 50 milliliters. So let's go ahead and pour in 50 milliliters, and let's just see what happens. Let's see what happens. And we can stir it up there. And let's take a look. Let that settle for a minute. And it's slowly, I don't know if you can see this. Ooh, look at that. I'm gonna go get a stirring rod and we're gonna poke around in here and see what's going on, okay? Ooh, and you ever seen a stick just stand up in water before? How about picking up? Oh yeah, that deserves something right there. Oh, let's look at that. How about picking up a graduated cylinder with a barbecue skewer? Huh. And I can pull it out. And you see these little gel, these little crystals, right? That's the sodium polyacrylate, and it's absorbed water, okay? Now, the fun part is when I do this. No way! Yeah, nothing, no leaks. Look at that. Look at that, no leaks. Now that's pretty cool, right? That's actually pretty cool. And I could even add more water. All right, let's add a little more to the top here. See how much more it can hold. There we go, and it's already, right, you can kind of see it. You can already see that material expanding. And that's impressive, right? So this can definitely hold a lot more water. So it's a little sloshy right now. But then as the water and the sodium polyacrylate comes up, you get that nice, look at that. What was that, like 5 seconds? This can definitely hold a lot more water. So we're gonna take a test and see how much water this can hold. Look at that, amazing. Cause look at that, see at the bottom right there? So it's definitely a different color. So there's still lots of water in here and you can touch it, right? It's a little wet, but we are gonna spread this out. So my, not even 1 gram of sodium polyacrylate, barely a gram. So far it has held, let's take a look, go down to our scale. All right, so remember we have this, so 24 grams, whatever weight this is, we're just gonna subtract 24. So how much water did my barely a gram of sodium polyacrylate hold? That looks like 96 grams. So I have 96 grams of water in here that's just stuck. Look at that. That's impressive. That's super cool. Okay, so let's go ahead and let's do our experiment of, and now we're up to 97, look at that. I mean, I can even add a little more. Let's tempt fate here. Look at that, just, oh, we're at 98. So we're gonna see how much water this can hold while still being a nice gel. All right, don't go anywhere. We're gonna get set up for that right now. All right, folks, we're back here. And so I spared you the video of me making another batch of sodium polyacrylate and doing surgery on my diaper, but seemed to get a little bit more. It's a good amount right there. And I got a couple little cotton fluffs in there. Let me go ahead and thank you. Thank you, sir. I don't need you there. Excellent. Okay, so, and I've got my 1 liter container here, and I've measured it. It looks like it's 1,296 grams. So I'm gonna go ahead and tear it out. 1,296. I'm gonna tear it out, maybe. So now it reads it as 0. So again, I'm gonna pour my sodium polyacrylate, and we're just gonna see, this is just an experiment, to see how much water we can get it to hold. And it looks like now, wow, I've got 2 grams. I actually did pretty well this time. Got 3, is it 2? 4? It's just gonna be climbing every time. Like 2 grams, okay, perfect. Interesting. All right, so now, let's go ahead and start pouring some water. So I've got 500 milliliters, which is 2 cups. And I'm just gonna pour 250 milliliters at a time. So it's basically a cup at a time. Pretty bold, but we're gonna see what happens. Here we go. So that's 250 milliliters, and I'm just gonna go ahead and stir this up, and let's see what happens. Stir it up there, and you gotta give it a minute to work. And let's see how long that takes before it starts firming up there. That's a cup of water, and already I start to see this gel. Oh yeah, it's working. You just stir it around a little bit. And now we're at 293 grams. We'll see if this is the ticket here. Oh, look at that, it's starting to form. Oh yeah. Maybe I went a little too ambitious here. Oh no, that was beautiful. Oh, look at that. You know it's good when I can stick my barbecue skewer in there and it stands up straight. Oh yeah. So now, oh, look at that, beautiful. It's got this nice, so we had what? 2 grams. We now hold 293 grams of water, so 291 grams, 293 minus 2. That's impressive, but look, we still got another cup to go. So let's go ahead and take it slow this time. I'm at about 250, a little more, a little less than that. There we go, 250. Let's do 100 milliliters at a time. So that'll take me down to 150. Beautiful. All right, let's see what that does. Oh yeah, I didn't even phase it. Look at that. Beautiful. So I got this nice gel here. Oh yeah, beautiful. Look at that. Doesn't smell like anything. All right. I'm still good, right? Now it's just because I've agitated it a little bit. Not agitated like as in made it mad, I just stirred it around. It's not gonna be stuck as much, but it's still holding plenty of water. I can still touch it, and I'm like barely wet. I mean, look at this. The great test is I take a white napkin, dab it, nothing. Look at that. I mean, oh, like crystals, right? It's not wet at all. Look at that, beautiful. All right, we got 150 more milliliters. Let's see if we can do it. Right now we're at what, 382 grams. Here we go. Ooh, I'll just do the rest of it. 2 cups of water. Let's see what that does. let's see what we'll just let it sit there. This is amazing, right? This is amazing. This is diaper science here. I mean, the amount of science and engineering that goes into making a diaper. So you could pee out like 2 cups of water and you're gonna be fine. Now it's starting to, oh, it's still like, look at that. Oh, look at that. I mean, it's starting to get a little, oh man. All right, let's do the little test here. Take my white napkin, dab it. No, not that kind of dab. So we're starting to get a little bit. 2 cups of water was about what it could hold. It's not terrible though, right? I mean, that's enough to wake up a baby. But, there we go. Not bad, right? And I still think it can hold more. I mean, you see that coming undone, right? I'm fairly certain we're gonna be able to put a little more in there. So let's go get some more water, right? We're at 518 grams. We gotta keep this going. That's more food coloring, don't need a lot. Stir it up. This is pretty cool. 518 grams, -2, so far our men's Big Lots brand diaper can hold 516 grams of water, which is not insignificant. So that was, here we go. So now it's starting to get a little gummy. So you can start to see, but I think the longer we leave it, it's gonna affect it. And I still think we're good. So let's go ahead and give it a minute. Right now we're at 645 grams of water. And that's just weight, right? We're not talking about volume, we're just talking about weight. I could measure weight, or I could measure volume. So we've already done 500 milliliters, and we're down, I had another 400. I'll do the math on that. Okay. We still good? Let's do our test. I mean, that's pretty impressive, right? Let's go ahead and take my napkin. That's impressive. So it's starting, there you see, now we're starting to get to the limits, right? Because now it's starting to come up pretty easily. Obviously, if your baby has peed out 2 cups of 2 cups of water, you probably want to change it. But it's still a gel, right? It's still a gel. It's just starting to, now you can see it's starting to kind of lose that nice, but it's still, I think we can get more water in here. I think we can get more. What do you guys think? Can we get more water in there? All right, I think so. So right now, 644. Let's see. All right, let's take a look. And then let's stir it around. Let's get some of that. There's probably some sodium polyacrylate at the bottom. It's like, I want to hold some water too. If it talked, which it probably does. You never know. Oh, look at that. Look at that. I mean, we're almost filling up, like almost a liter of water here. This is pretty close to a liter. When it gets to this right there, that'll be 1 liter of water. That's impressive. So far, we had 500 milliliters, and right now I'm at, 350, so this is 850 milliliters of water it's held. It's so awesome. All right, and now you can see, right, we're really starting to reach the limit. It's not as like, but look, there's still no liquid coming out. It's just all gelled up. All right, let's keep it going then. Let's see what we got. So now, let's take a look. I'll pour the rest of it. This will be 900, it's about 900 milliliters of water. Almost a liter. Let's stir it up. So yeah, now, right, so you can see my my skewer is really wet. And so now we're really getting into the limits of how much this can hold. But if you think about it, right, how much does this weigh now? 921 grams, okay? So our about 2 grams of sodium polyacrylate can hold has now held 919 grams of water, just wait. It's about 900 milliliters of water it can hold. And then even then, right, so now, see, now you're gonna start to see, you can kind of see, let me see if I can tilt it towards you, right? You can kind of see that edge of the water right there. All right, let's get it really down there. You can start to see how it's like very liquidy? Yeah, we're really at the limit of how much this can hold. But this is no small feat. Now you touch it and you're like, yeah, that's wet. That's no small feat, right? That it can hold this much. That is amazing. Round of applause, please, for sodium polyacrylate. Oh my goodness. Look at that, what hard work it did. I didn't do anything, I just poured water in there. This thing's doing all the work. That's pretty impressive. Okay, I think we're about done. Let's see, we'll pour it over here. So now you can see, so yeah, it's starting to drip out, right? But that's pretty cool. Okay, oh, look at that. That's just so fun. Look at that. Bloop, bloop, bloop. All right, very nice. Very nice. Looks like a snow cone, only you don't want to eat this. Look at that. Not too bad at all. All right, let's finish this up and let's talk about what's going on here. Okay, folks, we're back, and so let's just finish up here. So, pretty amazing stuff, right? Amazing that one diaper can hold that much water, right? And these are fairly large diapers. And then when you throw in the cotton in there, which will also absorb water, some of these diapers can hold about 800 times their weight in water, which is extremely impressive. We found out here, we start off with about 2 grams of sodium polyacrylate. I would probably say it's closer to 1, only because I think something happened with the scale because it looked to be about the same, but we'll go with 2 grams. And it held over 900 grams of water. 900 milliliters of water is exactly what I measured. So we found that at around 900 milliliters of water, almost a liter, it starts to lose its absorption, and then you start to get wet, just like that. And then obviously a wet diaper means a not happy baby, which means you have to change the diaper, which, yeah. But so some of these, right, diapers can hold up to 800 times their weight, which is pretty impressive. So what's going on here is we learned about polymers, right? And polymers are just repeating chains of monomers. And so when these polymers, you know, they're just repeat. When this sodium polyacrylate comes into contact with water, it loves water and it starts bonding to the water, starts sucking it up like a sponge. And it will do that until the sodium polyacrylate is saturated, right? Remember we learned saturated, it just can't hold any more water, and then that's when you get it to it gets really, really wet. But so far, I mean, that's a fairly impressive amount of water, or since we're testing diapers, a fairly impressive amount of pee. So, what's our extension here? Like, what could we do? Well, let's talk about other uses besides diapers, right? So this is great for diapers, but are you telling me this is the only thing we use it for? No, there's actually tons of uses of this hydrophilic material. There's a few listed here, but plants, right? Soils that need to retain water, you can put it in here. It also helps take out heavy metals in the environment when we add it to the soil. Here's the list of everything, but really, really an awesome, and it's non-toxic, which is, that's always a plus, right? Okay, so that is enough about polymers and diaper science. That's just a lot of fun. Yeah, and you can touch it, right? It's just kind of goopy. But again, yes, it's non-toxic. Please don't eat this. And this is another reason why they say don't throw diapers in the toilet. I don't think anybody does, but this is one of the reasons why. Imagine throwing a diaper in a toilet and it absorbs 800 times its weight in water. It's gonna quickly clog up the toilet, and that's not gonna be fun. Okay, this is Mr. C signing off. Woo. So I'm gonna have some fun with my sodium polyacrylate here, my blue goop, and I'll see you all next time for some more STEM with Mr. C. Bye.